do want to focus on sea ice because this is my favorite part of it all. This is what I work on an algorithm, a model to convert those microwaves to a measurement of sea ice. And how do we convert microwaves to sea ice? Well, let's focus on this left-hand panel for one moment. Here we have on our x-axis, this is our frequency of radiation, frequency of light. And this is actually, instead of wavelength, we're looking at, so it's what we call gigahertz is the unit. And so we have several different lines here. We have water vertical, water horizontal. Now, do not worry about vertical versus horizontal right now. It gets a little complicated, but just notice that for these two water lines, that the emissivity, the radiation the Earth produces in the microwave part of the spectrum, it increases as you get to higher and higher frequencies of microwaves. And now that differs from our two sorts of ices, sea ice. We've got first-year ice, and that is also vertical and horizontal. In both cases are first-year ice. Just to clue you in, first-year ice is ice that melts in the summer every year. It has pretty much the emissivity with frequency does not change much. It's all highly emissive regardless of your microwave frequency. And then our third type is the multi-year ice. That type of ice stays around for multiple years. You can see that type, the emissivity of microwaves decreases as you increase your frequency of microwaves. So this is all to say that the Earth emits this radiation, but the radiation that's being emitted is unique for water, it's unique for ice, and even the different types of ice that you have. And so you're able to model it. You're able to detect first-year ice, multi-year ice in ocean. And so here we have an output example of the sea ice concentration from the National Snow and Ice Data Center. And the values range from 0 to 100%. You can see that in orange, we are given the median ice edge from 1981 to 2010, median meaning middle. So it's similar to the mean, but not quite. What's interesting is what is this? This is 2018, this is November 22nd, 2018. The ice concentration is much less in extent as compared to our median ice edge. So what that tells us is the ice is shrinking in the Arctic. And we couldn't do that without microwaves, especially because on the right-hand side here, the visible snapshot of the Earth is very cloudy, and microwaves are able to see through those clouds. So remember X-rays, how you can see through the body and look at the skeleton? Well, in this case, microwaves, you can see through the clouds and look at the ice and ocean.